probability of getting a red ace when a card is drawn from random for an ordinary deck of cards. So, if we think about that sample space above, how many ways can I get a red ace? Because it wants to know specifically about getting a red ace. There's 2, and then the total amount of events you said was 52. So the probability is going to be 2 divided by 52, which gives me 0.126. I usually have someone divide it for me. 0.038, which means the probability of getting a red ace is 3.8%. Questions on that? All right, if a family has 3 children, find the probability that 2 of the 3 children are girls. Now we have to decide, they didn't specify, I'll specify like I said on the test, whether order matters or not, so we're going to find both of them. So we'll find the order matters and the order doesn't. So if we say that order matters, how many ways can 2 of the 3 children be girls? Well, if we go back up, we've got 4 where we're going to get at least 2 girls, right? If you want to specify to just 2 girls, you're looking at 3. But it didn't specify just 2. We need to have at least 2. So we've got the 4 out of how many? 8. Well, that's going to give me 0.5. So 50% of the time, you're going to have at least 2 girls when you have 3 kids. And how about when the order doesn't matter? How many ways can we get? At least 2? 2 ways out of the total of 4. Now, it's not always the case that the probabilities are going to match. It only happens sometimes. Yes? So if we're interested in just 2, so exactly 2 girls, then it would be 3 out of the 8, or 1 out of the 8. Or sorry, yeah. But if they don't specify that you only want that, you have that option where you have all 3 girls, right? Which means you do have 2 girls, you just also have 3 of them. Does that make sense? So the probability of 2 of the 3 kids being girls is 50%. Other questions? All right, let's look at our deck of cards. So if we're drawing a card from an ordinary deck, find these probabilities. So for event A, I want to find the probability of getting a jack. So probability of getting a jack, well, how many jacks are there? 4 out of 52. So what does that give me? 0.08. So the probability of getting a jack is 8%. I should just delete this because I don't like that part. The probability of getting the 6 of clubs. Well, how many 6 of clubs are there? So getting the 6 of clubs, there's only one of them out of my total 52. The reason I take the other part out is it kind of leads you to believe they're looking for a 6 and all the clubs, but I think the first part's better. All right, what does that give me? 0.2. So the probability of getting the 6 of clubs is 2%. All right, now this next one's a little different. The probability of getting a 3 or a diamond. So probability of 3 or diamond. How many 3s are there? How many diamonds are there? There's 13 total, and there's only 12 that we haven't counted yet, right? And it's still out of my 52. Does everyone get why we did that? So if we go back to our cards, we're saying we're interested in the diamonds, and we know that there's a total of 13 of them. But then it asked me about the 3s. And so that 3 would get double counted, and we only want to count each card once. So we have to eliminate it either when we're counting the 3s or when we're counting the diamonds. So we eliminated with the diamonds and said we only had 12 diamonds left, basically. Does that make sense? All right, so what's my probability? 0.31. Huh? The 4 plus the 12. So that's where we have 4 3s. And then we also have 12 diamonds. But one of those 3s was a diamond. So we had to eliminate the fact that we would count that 3 twice. So there's only 12 diamonds left that are new to our information. All right, I would put a sentence there, but I'm kind of running out of room. So I'm going to leave it there, and you guys could put the sentence of the probability of getting a 3 or a diamond is 31%. Now I want to get the probability of getting a 3 or a 6. How many 3s are there? How many 6s are there? Are there any overlap? Can't be a 3 and a 6, right? So we don't have to worry about subtracting anything or thinking about that. We just need to add them together, and we'll get 8 of our 52, which gives me 408. That can't be right because it can't be greater than 1. All right.
Oh, it's 0.15.
So there's a 15% chance of getting a 3 or a 6. Questions on that? All right. When a single die is rolled, find the probability of getting a 9. 0. That's one of those extremes where it is certain to not happen. One dice only has 1 through 6, so you can't get a 9. When a single die is rolled, find the probability of getting a number less than 7. It's certain to happen because all of the numbers are less than 7, so that's our other extreme option where you're guaranteed to get everything less than it.